We've just discussed reflection and refraction by considering particles. Let's revisit these two phenomena by looking at them as waves. We'll discuss Huygens' theory of light in the next section, but it is important here, while we're looking at reflection and refraction, to understand that these can also come out of a wave theory. The phenomenon of reflection occurs with waves as well as particles. We know that because we can go back to the AP1 unit on waves and the AP1 unit on sound waves and see just that. Refraction can also be explained with Huygens' theory of waves or light, as well as Newton's particle theory of light. Let's go into the idea of refraction of waves in a little more depth. If we were to think of light as a wave, then we know that we can relate the wavelength, lambda, and the frequency f, and the speed of the wave with one of the two following equations. In the vacuum, f is equal to c over lambda, that is, the frequency is equal to the speed of light in a vacuum divided by the wavelength. And in a particular medium, that frequency is equal to v1, the velocity in that medium, divided by lambda 1, the wavelength in that medium. The question you might ask is, are these the same frequencies? Well, when a wave changes speed as it enters from one medium into another, the frequency would have to stay the same. Otherwise, the waves would pile up at the interface between the two media. So we must have the same number of waves leaving one medium and entering the other, and therefore the frequencies have to be identical. That means that the wavelength of light has to change when it passes from one medium to another. If we begin with the two equations that we had on the previous slide, F equals C over lambda in a vacuum, and F equals V1 over lambda 1 in a medium, what we can see is that we can set the two equations equal, since, as we discussed, the frequency is constant. If we then rearrange this equation so that the speeds are on one side and the wavelengths are on the other, we get the following expression: C over V1 equals lambda over lambda 1. But we know C over V1 is just the index of refraction of that medium. And so we can see that the index of refraction is also equal to the ratio of the wavelength in vacuum divided by the wavelength in the medium.